Hello guys, welcome back. We're going to do another lesson in Unit 6 here. We're going to do 6-5, which is all about properties of special parallelograms. So today, mainly we're focusing on a rhombus, a rectangle, and a square. So what we're going to do is we're going to show that the diagonals of a rhombus are perpendicular bisectors of each other and angle bisectors of the angles. And then we're going to prove that the diagonals of a rectangle are congruent. And then we're going to use all these properties of rhombuses, rectangles, and squares, rhombi, to solve problems and just work through them. So no new vocabulary today. I know that we know what a rhombus, a rectangle, and a square is, but we are going to just review those really quickly. And then we're going to look at the properties. So what's the property of a rhombus, a rectangle, and a square? So let's go to the back of our packet to our terms page, and let's review those those three vocabulary terms. All right, so let's look here. We're in the back of our packet under terms, and we found where it says rhombus. Okay, so a rhombus is a parallelogram with 4 congruent sides. So all 4 sides are the same length, and it's a parallelogram. So since it's a parallelogram, a lot of things still apply, meaning opposite sides are still parallel. So these 2 sides are parallel, and these 2 sides are parallel. Okay, so that still applies. Also, opposite sides are congruent, or excuse me, opposite angles are congruent. So these 2 angles are congruent, and these 2 angles are congruent, right? So those things still apply. Everything that is true for a parallelogram is true for a rhombus. A rhombus just has a special stipulation that all 4 sides are the same length. Okay. A rectangle is a parallelogram. So again, since it's a parallelogram, opposite sides are parallel and congruent. So opposite sides are parallel and congruent. And it has it's a parallelogram with 4 right angles. So the only difference is that all 4 of the angles are 90 degrees. And that's it. And that's okay, because consecutive angles then are still add to 180, and opposite angles are still congruent. So it's just a special type of parallelogram that has 90-degree angles. And then the last one is a square. A square is a parallelogram. So again, opposite sides are parallel and congruent. The only difference is that all 4 sides are congruent. So all 4 sides are the same, which seems like a rhombus, right? But the only difference is that then I also have 4 right angles. So not only are all 4 sides the same, but I also have 4 right angles. If I had all 4 sides were the same, but I did not have 4 right angles, it would be a rhombus. So just having those 4 right angles is what makes it a square versus a rhombus. Okay. So now we're going to go down to our properties of special quadrilaterals, So we've done parallelograms. We did parallelograms. So here we are. Today we're looking at rectangles and rhombus and squares. So this is where we are right here. Okay. So again, because these are parallelograms, all the characteristics of parallelograms still apply. So we're not going to write down every single thing about a rectangle, right? Because we know that opposite sides are parallel and congruent, right? We know consecutive angles add to 180. We know opposite angles are congruent. We know that it has right angles, right? So we're going to talk about just the special characteristics of these shapes. So if I have a parallelogram that is a rectangle, So all the characteristics of a parallelogram are true, and that has 90 degrees, makes it a rectangle. What becomes special about that is that the diagonals of the rectangle are congruent. Okay, so A to C is equal to B to D. Okay, so the diagonals are the same. And where they intersect, cuts all 4 diagonals in half. So I'm going to add a little note here. Let's call this point E. So AE is congruent to BE, which is congruent to CE, which is congruent to DE, right? All of these are the same. So that's kind of cool. So not only are the diagonals the same, but they also cut each other in half. They bisect each other. Okay, for a rhombus, if I have a parallelogram that's a rhombus, meaning all 4 sides are the same length, but the angles are not 90 degrees. Okay, the diagonals are perpendicular, so the diagonals cross at 90 degrees. And the diagonals bisect the angles. Okay, the diagonals bisect the angles. So I can say that angle P, let's call this T. Okay, PQT is congruent to angle RQT, and that's congruent to angle PST, which is congruent to angle RST, right? So all of these blue angles are the same. They're the same measure. And I can say the same thing about the angles on P and the angles on R. All 4 of those angles are the same. So that's pretty cool. Not only do the diagonals are the diagonals perpendicular, but I know it divides all of those angles in half. And then lastly, if the parallelogram is a square, so now we're taking the properties of a rectangle and the properties of a rhombus and putting them together to make a square. So both of these properties are going to be true, right? They're going to cross at 90 degrees, just like a rhombus. And then the diagonals are equal, and they're going to be cut in half perfectly, just like a rectangle. Okay, so both the properties of the rectangle and the rhombus apply to the square. So those are the properties of my special parallelograms. What we're going to do now is we're going to look at some problems involving these properties. So we're going to go back to section 6.5 and we're going to look at example 1. Okay, so here we are back at lesson 6.5 in our packet. And example 1 says we're finding the diagonals of a rhombus, okay? So parallelogram ABCD is a rhombus. What are the measures of angle 1, 2, 3, and 4? Okay, so we have to remember the properties of a rhombus, that the diagonals of a rhombus are perpendicular. And we're gonna use the symbol, right? Diagonals of a rhombus are perpendicular. So what that means is angle 1 is going to be equal to angle 2, is going to be equal to angle 3, is going to be equal to angle 4. And since they're perpendicular, they are all going to be 90 degrees. So all 4 of them are the same. Okay. Then for part B, it says parallelogram JKLM is a rhombus. How are 1, 2, 3, and 4 related? Okay, so again, diagonals, we have to remember those properties of a rhombus. Diagonals bisect the angles. They cut the angles in half. Diagonals bisect the angles, cut in 2. So that tells me that angle 3 is going to be equal to angle 4. And angle 1 is going to be equal to angle 2. But in a parallelogram, opposite angles are equal. So if this angle L is the same as angle J and they're both cut in half, then that also means that angle 1 is congruent or equal to angle 4, and angle 2 is equal to angle 3. So really what it comes down to is angle 1 is equal to angle 2 is equal to angle 3 is equal to angle 4. Okay, because opposite angles in a parallelogram are congruent. All right, so we have a triad here. So let's look down. There we go. So this triad, the first one says, what is the length of WY? And the second one is, what is the measure of angle RPS? Okay, so, yes. Okay, so you might have to do like extra work here, right? You might have to find other pieces in order to find what it is you're looking for. I want you to take some time on these two because it's not always just intuitive, like, oh, it's 5 or whatever, right? So I want you to take some time and actually try these, start labeling things that you know and so on. And then when you're ready to go over it, go ahead and hit play on the video and we'll review it. Okay, so really hoping you guys gave this a shot here. And again, maybe just started filling in information. I know all of these are 5 because it is a rhombus and all 4 sides are the same. I also know that if z to the center is 3, then x to the center is also 3. And this is really what I'm trying to find, right, is one of these lengths. So a couple different ways that we can do it, but knowing that the diagonals of a rhombus are 90 degree or perpendicular, excuse me, so it's 90 degrees, I can draw this 90, oh, that was terrible, this 90 degree angle, right? That, so here's my 90 degrees. I know that this is 5 and I know that this is 3. So because I have this right triangle, I can use Pythagorean's theorem, right? A squared plus b squared equals c squared. And that will tell me my second leg. So it doesn't matter whether I plug in 3 for A or for B, but remember that C is always what's across from the right angle. So 5 is C. So I'm going to call 3A just because. So that gives me 3 squared plus B squared equals 5 squared. So it leaves me 9 plus B squared equals 5 squared is 25. If I subtract 9, I get B squared equals 16. And then when I take the square root and the square root, right, square root, I get B is 4. So that tells me that this length, W, halfway from W to Y is 4. That means that this is 4, which means this is also 4. So then the length of WY, we should be able to tell, is just 4 plus 4, so it's 8. And again, I don't have units, so I'm just going to write in units. So the length of WY is 8. All right. Now for B, all I know about this is that obviously it's a rhombus because all 4 sides are the same. I know that Q is 70, which means S is also 70. And then what I kind of see here is an isosceles triangle. I'm going to call this S, this is P, and this is R. So I basically took this triangle and redrew it. I know that this is 70. So what happens in my, this is what I'm trying to find right here, is RPS. So this is what I'm trying to find. But in an isosceles triangle, something very special happens. The 2 base angles are the same. So if angle P is X, then angle R is also X. So now I can set up the equation, right? X plus 70 equals 180. Because the 3 angles of a triangle add to 180. X plus x is 2x. If I subtract 70, I get 110. So I get x is equal to 55. So the measure of angle RPS is 55 degrees. So a lot of times on these problems, you can't just jump right away to solving for what the answer is, right? You might have to find other information first. Like here I had to do Pythagorean's theorem in order to find half of WY. Then I was able to find the whole thing. Or here I moved the 70 to the S and split that rhombus in half in order to have an isosceles triangle. So things like that, you don't always get to just skip to solving for what you want to find. Sometimes you have to plug in other information first. Let's look at example 2. It says quadrilateral ABCD is a rhombus, so all four sides are the same, right? They cross at 90 degrees. Okay, what is the measure of ADE? So ADE, this is what I'm trying to find right here. That's my X. So I'm gonna draw this triangle separately. I think sometimes it's really helpful. So here's E, here's D, and here's A. Remember, this is what I'm trying to find. I know that this is 90, and remember that the diagonals of a rhombus split the angles in half. So this means that this angle is also 53. So right here, this is 53. And I know that the three angles of a triangle add to 180, so x plus 90 plus 53 equals 180, right? 90 plus 153 is 143 equals 180. Subtract 143 to both sides, and I get x is 37 degrees. So the measure of angle ADE is equal to 37 degrees. And that's it. So sometimes kind of drawing those triangles separately could be really helpful. Okay, part B says quadrilateral GHJK is a rhombus. What is G to H? So this is what I'm trying to find right here, G to H. Well, I know that all four sides are the same, so GH I can also say is 3x plus 1, right? All four of the sides are 3x plus 1. So hopefully that makes sense. And this is really hard to tell in your notes, so hopefully you see that's 4x minus 7, and this is 2x plus 3. Okay, so the other thing about our rhombus here is that my diagonals are perpendicular, and they cut each other in half. They bisect each other, right? They bisect each other. So that tells me that 2x plus 3 is equal to what am I? Sorry, 4x minus 7. Okay, so I'm going to solve. Minus 2x minus 2x. 3 equals 2x minus 7. Add 7. Add 7. 10 equals 2x. Divide by 2. Divide by 2. X equals 5. That's great. We solve for x, but that's not what it's asking me to find. It wants the length of GH. Well, GH is 3x plus 1. So now I'm just going to plug in my value of x. So I have 3 times 5 plus 1, which is 15 plus 1, which is 16. So GH is equal to 16 units. So the length of GH is 16. So hopefully that makes sense. Again, we're just using those properties of our rhombi to solve these problems. So we have a couple of triads here. Okay, so our first one says LMNO is a rhombus. What is the measure of MNO? Okay, so you're going to find out what is that angle. The second problem, it says QRP or PQRS is a rhombus, and then what is the distance of QT? Okay, so go ahead and hit pause on the video, give this a try, do your best. If you mess up, it's no big deal, we can fix it, but it's better to try it than to not try it. So hit pause, try it, and then when you're ready to check it out, you can hit play and we'll go over them. Okay, so hopefully you guys tried this. Let's go over it. I'm given that this quadrilateral is a rhombus, so I know that all four sides are the same. And I want to know what is this angle. So I'm going to draw this as that isosceles triangle. So this is M, N, and O. And I know these two sides are the same. And this is what I'm trying to find. Right? And I know that this angle right here is 62, which means this angle is 62 as well, which means this angle is 62, right? So now that I know that, I can, do my equation. X plus 62 plus 62 equals 180 degrees. So I get X plus 124 equals 180. Subtract 124 to the other side. And I get that X is equal to 56. So the measure of angle MNO is 56 degrees. So hopefully that makes sense here. For part B, I was trying to find this guy right here, QT. I don't want to use X because I think that's confusing then because we have Y's as their variables. Okay. So let's look here. I know that these two side lengths are the same because all four side lengths are the same. So I can take my 3y minus 1 and set it equal to 2y plus 3. Minus 2y minus 2y. Y minus 1 equals 3. I'm going to add 1, and I get y equals 3. So that's great. That tells me what y is, which is perfect. Now I'm given that q to s, so qs is equal to 5y minus 4. So I have 5 times 3 minus 4, which gets me, oh my goodness, you guys, why don't you yell at me? 3 plus 1 is not 3. It is 4. It's like, this doesn't make any sense. So x is 4. There we go. 5 times 4. This makes a lot of sense. Which is 20 minus 4, which is 16. So QS is 16. But that's not what it's asking me to find. It wants the half of that, right? The whole thing is 16, then half of it is 8. Remember that in a parallelogram, the diagonals are split in half. So if the whole thing is 16, then half of it, QT, is 8 units. Okay, we have another try it here for you guys. So let's scroll down and look. Here we have the measure. We're given that the measure of angle QPT is 24. So this right here is 24. What is the measure of PST? Okay, so again, work through, see if you can figure out, all these different angles. Go ahead and hit pause on the video and try and figure it out. And then when you're ready, hit play and we'll look at it. Okay, so let's look at this. There's a lot of different ways that you can think about this. But one way is just knowing the properties of a parallelogram. So if half of P is 24, then all of P is 48, right? Which means this is also 48. And I know that consecutive angles add to 180. So I can do like 180 minus 48, and that tells me that this is 132, right? And remember, this is what I'm trying to find here. So if I take that and I cut 132 in half, that gives me 66 on one side and 66 on the other side. So the measure of angle PST is 66 degrees. So that's one way you could have done it. There's a lot of different ways that you could have thought about that, but as long as you got 66, then you're good to go. Okay, so we're actually going to skip example 3, which is the proof that diagonals of a rectangle are congruent. We're going to look at this, try it, but really what we're going to do is just kind of jump down and start practicing, okay? So here it says a carpenter needs to check the deck his apprentice built to make sure it is rectangular. The diagonals, so here we have a rectangular deck. The diagonals are 52 and 53 inches. Is the gate rectangular? Remember that in a rectangle, the diagonals have to be equal. Since they are not equal here, no, the gate is not rectangular. And then it says explain. So I have to have because. Okay, in order for it to be rectangular, those diagonals would have to be congruent. So here the diagonals are not congruent. Are not congruent, so therefore it is not a rectangle. Okay. So again, just using the fact that rectangles have these diagonals that have to be equal to each other. So again, we're going to skip example 4, but we are going to do the try it. So we'll do some of these together. So we'll do one together and then you guys will try one. Okay. So here we have a rectangle with area of 1,600 meters squared, and it's 4 times as long as it is wide. So what I'm going to do is I am going to draw a rectangle. And I'm going to say, it says, what is the sum of the diagonals? So I'm going to draw on the diagonals too. Okay, so it's 4 times as long as it is wide. Well, I don't know how wide it is, so I can call that x. And then it's 4 times that long. So 4 times x, right? Hopefully that makes sense. And then I'm given the area, and hopefully we'll remember that the area is equal to the length times the width. So in this case, the area is 1,600. I'm given that. The length is 4x, and the width is x. So now I can kind of solve this. So I have 1,600 equals 4x times x is 4x squared. Yeah, I'm going to divide by 4, and I get 400 equals x squared. Okay, I need to get rid of the squared because I just want x, so I'm going to take the square root, and the square root of 400 is 20. So I get x equals 20. So that's exciting. So that tells me, I'm going to kind of switch up a color here, that tells me that this is 20, and 4 times 20 is 80, so this is 80. But what it doesn't tell me is what the length of the diagonal is. So I'm going to have to figure that out. So here is half of my rectangle, where this is 20, and this is 80. Okay, so I'm going to have to use my Pythagorean's theorem to find out what C is. Remember, C is always the one across from the right angle. So A squared, let's do 20. So 20 squared plus 80 squared equals C squared. And so you'll probably want a calculator here. 20 squared we already know is 400. And then 80 squared is 6,400. And that equals C squared. So if we add these together, I get 6,800 equals C squared. And then this, you take the square root, right? You take the square root, and I get that C is equal to 82.5. So the diagonal length here, do it back in this red, is 82.5. So one diagonal is 82.5, and since it's a rectangle, the diagonals are equal, so I know that the other diagonal is 82.5. So then it's asking us what is the sum of the diagonals. So the sum is going to be equal to 82.5 plus 82.5. Add it all up, and I get that the sum is equal to 165. Then what's the units? Right here it tells me that it's meters, so it'll be meters. So both the diagonals added up gives me 165 meters. Okay, I want you guys to try this next one. Okay, it says a volunteer group is planting a butterfly garden in a portion of the rectangular park. What is the perimeter of the butterfly garden? So I want to add up all three sides of this triangle. So I might have to do some work to figure out what those sides are. So go ahead and pause the video, see if you can figure it out, and then when you're ready, we'll hit play and look at it. Okay, so let's look. So again, in this butterfly garden, I know that KL is 160 feet because it's opposite, right, of JM, and a rectangle has opposite sides are congruent. Okay, then I have this right triangle. I'm going to draw it like this, where this is 100 because it told me. And this is 160 because it told me. This is 90 because it's a rectangle. And so I want to know what C is, right? I want to know what this is. So again, I'm going to use my Pythagorean's theorem, keeping in mind that C is always the side across from the right angle. So I'm going to say A is 100, but you could also say A is 160. It doesn't matter. Plus 160 squared equals C squared. Okay? And so we do the math on that. 100 squared is 10,000. 160 squared is 256, or sorry, 25,600. My bad. So if I add these up, I'm going to get 35,600 equals C squared. Okay, take the square root, take the square root, and I get C is about, and I would just round to the nearest whole number here. So it's 188.679, so I'm going to just say 189. Okay, so this whole length from K to M is 189. But I don't want the whole length. I just want k to n. So I'm going to take 189 and divide by 2, which gets me 94.5. So if that's 94.5, then I know that this is also 94.5. And now I can find the perimeter of this garden, right? So the perimeter is equal to 94.5 plus 94.5 plus 160. And I get 349. And then don't forget your units. So I'm just adding up all three sides of my triangle. Okay, so we've kind of covered rectangles, and we've covered rombi. So we have one example left that's about squares, and then that's it. So this says figure WXYZ is a square. Since it's a square, I know, right? All of these guys are the same. I have right angles, all sorts of fun stuff. Okay, if WY, so the diagonal, plus XZ, the other diagonal, is 92, what is the area of WPZ? Okie dokie. So we got some fun stuff. In a square, not only are the diagonals the same length, okay, but they also cut each other in half. So this length and this length and this length and this length are equal. So if WY plus XZ equals 92, that means that the length of WY is half of 92, which is 46, which means that XZ is also 46. So WY is 46, and that's great, but what about if I want to know WP? It'll be half, again, of 46, which is 23. So I know that all of these lengths are 23. Okay, so hopefully that makes sense. Because this is a square, I know that these guys cross at 90. So I'm just going to take this blue triangle and I'm going to kind of rotate it slightly. So here's W, here's P, and here's Z. And this is what I'm trying to find here, X. And I know that WP is 23, and I know that ZP is 23. So again, I have a right triangle. I can use Pythagorean's theorem. A squared plus B squared equals, in this case, I'm going to use X squared because I've labeled it X. So 23 squared plus 23 squared equals X squared. So 23 squared is 529, so 529 plus 529 equals X squared. Okay, so 1058, if I add those two together, I get 1058 is equal to X squared. And then I get X is about, let's kind of round it to the nearest half. I have 32.52. So let's just do 32.5 units. Great. 32.5. Okay. Now I can find the area of this triangle. Hopefully you remember that area is equal to base times height divided by 2. Okay, because it's a right triangle, my base is 23, my height is 23, and I'm going to divide by 2, which gets me 529 divided by 2. So the area of this triangle is about 264.5. I don't have a unit, so I have to write units. And because it's area, it's units squared. So because it's area, it's units squared. Okay. The last one, I think you guys can do on your own, so I want you to try it. But again, I'm a visual person, so I'm going to draw it. I have square A, B, C, D. Diagonals are AC and BD. Right, so I just have this drawing. What is the measure of angle A to B to D? Okay, so go ahead and hit pause if you need to, but go ahead and find the angle of ABD, which is this angle right here. And then when you're ready to review it, you can hit play. Okay, so we're trying to find the measure of angle ABD here. So things that we have to think about. A square is a rhombus. Okay, so a square, I'm going to write this. A square is a rhombus. My pen is jumping. So a square is a rhombus, so the diagonals bisect the angles. So the diagonals cut the angles in half. And just that fact alone is going to be enough for us to be able to figure this out. Because I know that the whole angle B is 90 degrees. So if the diagonal cuts that in half, then angle ABD is going to be half of 90, which is 45 degrees. Okay, so hopefully we're feeling good now about rhombi and rectangles and squares. If you have any questions or you need any help, again, always reach out, advocate for yourself, ask what you need to ask, things like that, and we will definitely get to helping you. So if you need anything, reach out. Otherwise, have a wonderful day.